All right, cool. Hi, good afternoon for me and whatever it is, wherever you are in the world. So we have got a, minimally working RTP package going, and we've got a tiny little high-level interface to transmit packets and receive packets. Very minimal and high level. A lot of things aren't supported, but it's kind of tricky to know what to support unless you really start transporting stuff. So the most common uses of RTP are, the ones that we're most familiar with are going to be things like, voice calls, WebRTC, video calls, this sort of thing. But there's an interesting one that I'm personally interested in, is transporting this video over RTP, JPEG XS. So this isn't like the JPEG that we know. This isn't JPEG XL, which is interesting on the web. This is a video codec used for low latency, high bandwidth, controlled network environments. The idea is that they're trying to replace SDI, which is a cable that looks like this. And then you have SDI. We're going to have things here. Yep. This is, you'll see these, boxes. These are used instead of HDMI for like longer cable runs. The current bandwidth of, there's SDI 12G now, which is like 12 gigabit over one of these cables. The thing is that it's not IP, right? So you can't switch it, you can't route it. I mean, sorry, you can. Of course you can. There are SDI routers and stuff like that. But, now with a lot of things running over IP, there's an opportunity there to kind of make stuff, more stuff IP. JPEG XS is one way of doing that. So it's a super simple codec apparently. And what it means by simple is that it's like low implementation complexity. Now, this is way, all this stuff requires knowledge that I don't have. I've never looked into it too hard. But what I'm personally interested in is that when they talk about all this simplicity and all this stuff, is that the devices can be very basic. So what's needed to actually decode or encode the frames is, can be super rudimentary apparently. I like that idea. Of course you need like a fat pipe, but just interesting. This is pretty new. I think it was really published like 2 years ago. And the way to transport JPEG XS video in RTP, this was done, here we go, published 2021. Okay, so I've not been able to find any open source code that deals with this sort of thing. So I think this is going to be somewhat of a world first, which is either like very cool or really fucking stupid, or both. I don't think I'm going to get very far because it, quickly gets, you quickly need to understand about JPEG XS itself as opposed to just RTP. So just a recap of what we've really been up to, what this is going to look like. Oops, sorry. Let's do this again. This is going to be up here. All right. So let's look at what we have for RTP here. Packet. Okay. This is a packet. So we've got the header, and the payload for us is just a slice of bytes. We don't know anything more about it other than that. In the header, got a little, the information that's, required to do some kind of synchronization, reordering, that sort of thing. Now, what we're going to do is, what we've already done is we've worked out how to transport text in the payload. And we have a test that every time we run, do this, when that passes, what's actually happening is that we're connecting to ourselves on the loopback interface, and we're actually creating an RTP stream, streaming it to ourselves, and making sure that everything kind of matches. And that's what we got going last time. So that's a cool little test to make sure that, we're able to, of course, decode, encode packets, but also manage a little bit of the stream. Our payload is super simple. It's literally just UTF-8 encoded text. So it's just, the bytes are the bytes. Super simple. With RTP, we're doing, obviously the payload is going to be a lot more complicated. In the payload, what I want to do for this particular stream, for this, like our little session right now, is at least try to get, to reach into the payload and at least be able to manage the RTP, the JPEG XS RTP header. So this looks like this. It's 4 bytes. This is going to tell us a little bit about what's in the payload, how it works, I think. Let's just start hacking because, so we've done the RTP, now we're just going to go a little bit lower. Oh, sorry, I just realized with no dot, it's not now for me. All is good, get your said, what about you? I'm going to write a couple of go again. Add you in the last. Hey. All right. Hey. Hey, how's it going? Yeah, well, we're just gonna, just a little bit. Just a little bit. I don't think so. There we go. Will do. Work with me page on my site new. Yes. Let's see. Yeah. Yeah, it is Irving. Yeah. How are you going, by the way? I'm just gonna, let's see, so this here. Yeah, let's just get going. So we got our busy work past couple of days. Okay. Oh, even over the weekend? When I go follow it to Shane, is it? Oh yeah, okay. Cool. Oh yeah. Packetization mode. Oops. This indicates code stream packetization mode. Indicates slice, so code stream or slice. Yeah, right, okay. So that means that, yeah, okay. So it looks like every single packet will have this header when we're dealing with the JPEG XS. For all packets of the RTP stream. Yeah, interesting. Okay, so this is to say that when we have a frame, T-bit is set to indicate that packets are sent sequentially by the transmitter. I want to give this a little bit more meaning. So I want to call this sequential. K equals 0 indicates code stream packetization mode. Slice. So this is about code stream or slice. It's 1 bit, so all packets. Okay, so let's do code stream mode or just code stream. Yeah, something like that. I mean, this is, let's do this. Yeah. Yeah, yeah. Sorry, I just realized I missed it. Whatever, it's past couple. Yeah, just had the weekend, so I was just taking, just spending time with my partner, just having fun. Yeah. The resolution of the monitor. So this display is actually What do they actually give this thing? The native resolution is 4480 by, yeah, let's send this through. All right, here we go. That's the resolution. Yeah, and then, yeah, indeed, yep, source is 1080p, yeah, at 25 frames per second. Zero is one because slice wouldn't make sense. Yeah, I think so, yeah. Yeah, I think that's right, yeah. Yeah, exactly, yeah, this should really be packetization, but it's like it's like, I don't know, it's weird, I don't know quite how to do it, yeah. That's exactly, yeah, because it says here that the k bit shall be identical. I'm sorry, the yeah. Where was that again? The transmission mode is set to 0, yeah. So in slice mode, yeah. So it's kind of, it's almost like maybe we could. Maybe what we could do is store it as a kind of a, we can do something like, because only slice packetization mode supports it. Yeah, right, okay. So I could document that as well. Hey, how's it going? Hi. Ah, they're doing the compiler in Rust, right? I was just watching you. How did it go? Lorraine. Nice. Well done. Well done. Yeah. Oh yeah, of course. Oh no, but no. This is actually on my Mac, but I was doing it on my OpenBSD machine, but because my head was really starting to hurt looking down at the screen. Oh yeah, right. Yeah, and so yeah, but my neck was really starting to hurt, and my actual OpenBSD, that's my laptop, my desktop is, well, I haven't figured out how to set it up here yet. Haven't got enough room, basically. Yeah. Hey everybody. Yeah, but so what we're doing here is, at least what I'm pretty sure, is the world's first open source JPEG XS. Also, this is a good day. We'll set up sooner rather than later. I hope you. That's not really okay. Thanks, Wayne. Have a good evening. Thanks again. The FK. Yeah, so what we're doing is we're working on. I should probably just go through because there's fuck yeah, there's heaps of people here now. All right. JPEG XS is a new video codec, even though it's JPEG. It's a low latency, what do you call it? Intra-frame video codec. So this isn't like H.264 or like AV1 and Newell one, or this is one that like pretty much sends you, frame by frame. More like film, like 35mm film video. And so this is a new codec that's meant to be like super low latency, low implementation complexity. So where the hardware required to actually decode this thing is, and you could do it on with minimal resources apparently. Now actually going into the frame and decoding it and getting all the colors out of it, I'm not going to do that because that's we're not quite there yet. But what we are doing is that we've done a little RTP package, which is the network protocol used in like FaceTime, in WhatsApp, Zoom, Slack calls. It's used to transport audio and video, low latency, so it's just over UDP. And we've just done text payloads with it. So we can send and receive text payload. So we've decoded it, whatever. Text is a pretty easy payload, and we've done that, to have some like automated tests. But what we're going to do is we're going to try to reach into the payload and implement a, let's say, like part of the JPEG XS RTP payload format spec. So this way we'll be able to maybe manage, JPEG XS RTP streams. It's a pretty new codec. It's only been out for like a couple, 2 or 3 years. And right now, as I said, like I can't find any open source code that deals with it. I haven't actually been able to find any open source like codecs, full stop. So yeah, this could be interesting. It's meant to be used in like broadcast environments or just things where you've got a fat pipe but dumb devices. Unreliable networks, that sort of thing. Yeah. So, just gonna try and like just do this very initial bit of it and just sort of see where we get to. And then from there, I think I'm gonna have to ask around and see like, because I'm not even sure where to, I don't know, like I need to find some JPEG XS streams. I need to find some video. And yeah, I'll need to ask around for that. Temporal sparse voxel drags. Oh yeah. I have no idea what that is. Temporal sparse voxel. Oh, JPEG cyclic graphs. Yeah, right, okay. Yeah, right. What's that? Okay. Oh, indicate slice. Okay, so. So this is, if it's false, the slice All right, let's see. So, right. Progressive or interlaced, okay. Which JPEG XS feature is failure? So let's see, let's understand a little bit about the interlaced information. Progressive, reserved, interlaced, interlaced, okay. Five bits is there. Okay, let's store this maybe as is. So let's go like, let's do a new type here, interlaced information. So do scan. Scan mode maybe. I'm gonna do here, so 2 bits, and we'll just store it, like we'll have our values stored as it would appear in the byte, because this is a fixed size. So then this is going to be like OB 1, 2, 3. So that's sequential packet mode last. So 1, 2, 3, and then we got, oh, it's just 0. Okay, that's, yeah. Okay, that's, this one here is reserved. So let's do that. That's 1, and then we've got 2 and 3. Okay, so go scan mode. How are we going to call this thing? So interlaced video frame. Yeah, I know. It was so funny when, yeah. No worries. Yeah. It was funny when I hopped on. So, so is the compiler. That's cool. And then I hop on and I go, wait, what's up with this guy's accent? All the best, mate. Thanks for streaming before. It was good. Interlaced. We'll go scan mode. Second. And those are all of the values that we're allowed. So we've got 0. Oh, sorry, I haven't got this right. Yeah, so this is scan mode. Get rid of this. 0, sorry, so it isn't actually that. It's 0, 1, but actually it's 1, 2, 3. 1, 0. 1, 2, 3. All right? Yep. And then this one is 4. 1, 2, 3, 4. 1, 2, 3, 4. There. Hey Sanjay, is this a private project? I want to read the documentation for this low-level streaming. Yeah, so the source code is here, if that's what you mean. Otherwise, where's GitHub? And then from there, if you're interested in the code documentation, probably better to go here. And then go to streaming. So let's do that. And then, yeah. Now, other documentation. Okay. Yep. Yeah, no worries. Yeah, that's yeah, it's coming along. It's not all documented, but it's always a work in progress, right? It's never done. Yeah. If you find anything that's like really confusing or anything, it would be super helpful if you where's the list down here? You can just email it to the mailing list if you're up for it. No pressure. Alrighty. Yeah. Okay. Interlaced. I'm going to call this maybe like interlaced. And then, yeah, at least it's got the same name. Okay, the F counter. 5-bit. Awesome. Love a good 5-bit number. Very useful. Let me just check the YouTube thing is all right. Yeah, looks good. Okay, nice. Oh yeah, thank you. Oh man, hey! Thanks very much, Feisty Lobster. Good morning to you, I think. 3 hours back? Yeah. Is that right? 2, 3 at the moment? Yeah. Super kind, man. Thanks so much. That's awesome. Yeah. Thank you. Hey, listen, thanks so much. That's super kind. Yeah. So frame counter identifies a video frame number mod 32 to which a packet belongs. Okay, may help the decoder manage its input buffer and bring packets back into their natural order. Okay, makes sense. So, yep. That helps because these things aren't really, you can imagine like a whole bunch of things are going to be arriving out of order or, yeah, that's good. Bit of a higher level sort of like sync counter thing. As opposed to just looking at timestamps and stuff like that. This kind of gives you a little bit of a, yeah, as I said, like a high level sort of sync source. Slice an extended packet counter. $11 bits. Now they are just counters, so, and it's 11 bits. So let's do that as a, I really don't want to call it sep counter. It's like, what, I don't like having a slice and extended packet counter. Slice modulo 2, which is packet contributes. Okay, so code stream packetization mode. This counter resets whenever the packet counter resets. So packet counter is C section 4.4. That's further down. Okay. The future has been very nice. Yeah. I hope the past is working out for you right now. I'm going to call it sep counter, I know. And then we're going to have the packet counter, which is also at 11 bits. Okay. And that is apparently our header. Let's document this stuff. So that's that done. Let's format that. Packet mode, yeah, okay, last. I think there's going to be a nicer, look up this, there's going to be some nicer wording for this, because I'm not, scan mode, interlaced info, what's the, get a nice deinterlacing. Nice word, sort of. Yeah, can't quite get a nice word for this. So maybe which all the lines of each frame are drawn in sequences in contrast to the... It's like a technique for... Yeah, I didn't say that. Yeah, no, look, let's just leave it like that. All good. What is this text editor? This is Acme. Is that it? Okay. Yeah. In the Twitch, my Twitch channel about page, whatever you call that, there's a link also to a video which does a walkthrough of the editor, which I think is very good. Gives a good feel for what the thing can do and what it's good at, what it's not good at, that sort of thing. Okay. Maybe just that. Okay. Frame count. So this is going to be a 5-bit integer. Mod 32. Yeah. Modulo 32. Probably good. Yeah, and then this count elements as to which the packet contributes. Yeah, okay. The holder, let me know how to. of either the slice how are we going to say this? Because this is depending on our packet mode. Of an integer of yeah, let's just, okay, let's do that. Sep counter holds an 11-bit integer. That's for sure, right? That's clear. Now let's go on to say if then sep counter holds is incremented by 1 whenever packet counter, which we got that whenever packet counter overruns. Packetization mode is, let's do this in, almost need like a different line altogether for this stuff, like that. So depending on the value of packet mode. There we go. And packet counter overruns. Okay, that's, and then, so if it's is slice, then sep counter identifies the slice modulo 2047 okay, yeah, I can just do that same wording. I think it's good. If the data belong, okay. Okay, that's good. All right, let's do that. Tricky. All right. Okay, last field. So the packetization unit. So this is, you know, really going into, yeah, this sort of, basically the payloads are actually like the payload is fragmented. That's what this packetization unit is. So that should tell us, yeah, so there's a PU1, PU2, but I think that this stuff is actually in a, I think, sorry, it's not necessarily fragmented, but what I mean is that I think that you can have a few of these in one RTP packet payload. I think that's it. But we'll get to the payload. We're just looking at the header. Alrighty. Oh, sorry. Any particular reason to choose Go for the task? Oh, I'm just familiar with it, basically. I think that, yeah, that's, at the end of the day, that's pretty much it. Yeah, it's, Go has worked well in, like for this kind of work before for me. So yeah, that's pretty much it. Yeah. There's some pain around, you know, when you're doing these, when you're dealing with bit fields and stuff like that, because there's no such thing in Go. Like there's no, you know, like native way to represent that kind of data. So here I've got a, you know, 11-bit integer. I have to use a uint16 for that. So, ugh. And then, yeah, when you start like packing bits in, then it gets pretty annoying because yeah, just a bit of a pain, but it's okay. Yeah, a few bugs, sure. Yeah, you gotta chase down those bugs, but then, you know, with the concurrency and stuff, you know, you can kind of saves you a lot of other bugs elsewhere. So classic trade-off stuff. Yeah. Yeah. Yeah, that's the built-in libraries. That is actually another good point. Yeah, like I gave a little bit of info about it in a talk I gave. Yeah, one of the things I think is that, you know, with Go, like a lot of people see Go used in web development and like this kind of public cloud infrastructure kind of stuff. And yeah, that's cool. Like that sort of thing is interesting, but I don't know, like there's so much more in the computer world than just web development. And so I think using Go in this kind of context is, yeah, kind of like I don't know, it's kind of like an interesting experiment or something to see how it works. Yeah. There's more to the web. Yeah. So, yeah, I think people like automatically associate this kind of work with C, and that's it, right? And I think that the projects that I've been like in this sort of TV station setting and these kind of video streaming things, yeah, like, you know, seg faults, you know, like, I don't know, just C stuff is yeah, that has its own problems, that it's been really interesting to use Go in those settings because, you know, with a strong standard library and a very stable language in the sense of like that backwards compatibility thing, which of course is a problem in other ways too. Yeah, absolutely. But in these kind of settings where like you write a thing and then you just leave it for years and it just sits there and runs on like some old Linux VM that never gets updated. Yeah, that's worked really well in these kind of settings that you'd think would absolutely need to be written in C. Okay, because it's low level enough to do most things, e.g., yeah, so Feisty Lobster says, I love Go because it's low level enough to do most things, like low level socket programming, that it also helps you to have a better understanding of how things actually work. Most languages would abstract it away. Yeah. And that's it. So you're kind of able to like, I don't know how to say. Yeah, it's not too far of a stretch to just go into the raw bytes of things. Alrighty. Hard, yeah. Yeah, it's all, you know, it's all about context and stuff, right? Yeah. Yeah, exactly. Yeah, that's it. Yeah. Sanjay's, oh yeah, let me put that. That's the video there, Sanjay. To have architecture diagram of this library, like how to feed media, how to insert in between using Scuddy 35, etc. No, I don't. I kind of, yeah, haven't really done any of that kind of higher level stuff. I think, yeah, they're kind of, in a sense, there isn't an architecture, if that makes sense. Like each one kind of works independently, I guess. Hey, Travis, how you going? So what I mean by that is that, you know, like all of these things can and do operate independently. I guess the higher level architecture would come in, you know, actual applications that could be developed using these things. But yeah, I haven't really gotten to that kind of thing yet. There's a tiny little bit, for example, like in our M3U8. So in an HLS playlist, you can have a... Sorry, I just realized you couldn't see what I was looking at. But yeah, like I was just saying that for each of these packages, they're kind of in, you know, yeah, they're just different specs just implemented. And so if you go to M3U8, there's a little bit of that. Date range, yeah. So here's one where, you know, in a certain HLS playlist tag, date range, you know, instead of like putting in, you know, like raw hex values or something, you can just, you know, provide a pointer to a Scuddy 35 splice. So the way that, how that compares with, for example, the existing another one. Yeah, this one. Okay, so just to compare, this is a M3U8 package, you know, for HLS, and this is a popular open source one, although it's not maintained anymore. So, and if you look at, let's go to our variant Scotty. Okay, here we go. Right, so if we look at like this Scotty thing, I mean, float 64, like what is a Scotty? So there's things like that, yeah. So there's a date range. Defines the format that we should not use. Custom tags. Yeah. So the idea is that to kind of have these bits that could work together but don't necessarily need to. And what I notice is that a lot of the systems out there will kind of pull in many different packages, like from different repositories, which means, you know, we all know about dependencies, right? And how much of a problem it can be sometimes. So the idea is to just kind of develop this thing to kind of get a feel of like how, you know, what a kind of almost like a standard library of kind of AV, like audiovisual streaming, could look like. A lot of people use FFmpeg for this stuff, which is an amazing, amazing project, right? Like that's just unbelievable. But it's been fun to kind of like just do the protocols separately and the data formats, and yeah, learning a lot on the way. Just to give you an idea, like this, there's some software that I've written for, you know, companies that, in a sense, you grab bits and pieces from this stuff, and then the actual application code has been quite small. Yeah, so that's the kind of idea, and that's kind of why there isn't an architecture per se, because yeah, like the applications themselves will probably pull in bits and pieces, and yeah, that's been fun. All right, so that's our header. Now what we're going to need to do is the video encoding myself here, just saw that temporal box thing in passing, and I think it'll be cool. Yeah, for sure. Cool. Ah, interesting. Yeah, right, okay. Yeah, right. Yeah, I've not done any of that. So I'm kind of just slowly working my way down to it. So I started at the top with like the transport protocol, and now, you know, then you got the payload, and then just slowly getting to the payload, the header, and then, you know, kind of work my way down. Anyway, so this looks like we're good here. So we could probably, I'll just make sure this packet counts. Yeah, so packet number is an 11-bit integer identifying the packet number within the current packetization unit. Right, go. Right, save that. Now, oh wow, no way. Oh, that's awesome. So it's like the image and the audio codecs used for PS2 and GameCube. Yeah, wow. It's cool. Super cool. Well, hey, look, I mean, if you're interested in doing the world's first JPEG XS open source video codec, then hey, you know, I'll be gladly taking any advice. So, I mean, we could almost start looking at this packetization unit. So in this case, the payload data consists of concatenation of multiple, yeah, see? So the payload consists of a concatenation of multiple JPEG XS frames. Yeah, okay. So one packet will contain concatenated multiple frames. Will contain concatenated frames. Each video support box in the RTP stream shall define the same subboxes. Each frame is a concatenation of one or more packetization units. Okay, there we go. So a packet has, right, so let's draw like a little diagram or something. So you've got the payload, and then within there you've got, say, oh, no. Each stream consists of frames. No, okay, so no, we don't know how that fits in with the packet. So let's leave that. Within an RTP stream, all the video spokes on the shell are thus each video spoke shall define the same. Each JPEG frame consists, is a concatenation of one or more packetization units. So let's see. All right. So let's say we've got the, hey FitRider, how you going? Okay, so the payload is going to have frame, right? So it's just going to be loads of frames. And then within each frame, you're going to have PU, one or more packetization units. Okay, so you can have PU, and then you could maybe have another frame which maybe just has one. Maybe have another one that has PU, something like that. And then PU, and then forever until the thing runs out. Okay, so payload data, code stream packetization mode. Wait, did my rain not go through? Oh no, sorry. Yeah, it's because I don't see raids on this. Hey, OpenJ. Oh yeah, oh yeah. Hey everybody. Sorry, my shitty IRC thing here doesn't show a lot. Yeah. How are you going? What were you working on? Hey. Hi, hey. Geez, lots of people today. I'm not used to so many people on a plain JavaScript game. Yeah, cool. Nice. Cool. Oh, yeah. Oh, well then, welcome back, I guess. Oh, yeah. Yeah, I love that. You should look. Listen, you should tell my. You should get in touch with my friend. He loves like. He's a front end. Like for work, he's a front end developer. But he's truly like a full stack guy. So this sort of thing where just implementing it like in just pure JavaScript, like he's so good at that stuff. And he went to like a video game development school or something like that. So let me send him your username so that, let me just save that. Actually, twitch.tv/that. Wait. What is the character count limit on Twitch? Hey Kai314, welcome back. The character count limit, I don't know. You mean in like one message here? In chat? Oh, 500, okay. Yeah, there are a lot of viewers, yeah. This is definitely... It's funny because this is probably going to be like, it feels like one of the most boring ones because it's like, source file, push limits on it. Oh yeah. Can't look into machine learning stuff and generating STFC messaging. Oh wow. Code stream part 1, part 2049, okay. For an interlaced video frame, the code stream packages for the progressive video frame, the slice packetization mode. What is it? Try to copy and paste a giant ass source file, push the limits that way. I don't know. Yeah, I haven't adjusted any settings, so I guess there's fortunately some safe defaults there, I guess. You can chuck it on a paste bin or something. You know, like a web paste thing. Okay, there you go. What kind of UI is this? Yeah. That's some info on the editor. But the best one is actually, look, let me link this just for people who are interested. What's the tour? That's it. And then, packetization units as explained in section 4.1. So it looks like, okay, so how this stuff is actually, I just wonder whether the packetization unit is, here we go. Here we go. Makes sent over multiple packets. The payload of every packet shall have the same size. Yeah, based on, yeah, okay. Possible set for last packet with boundaries shall coincide with boundaries of payload of a packet. Yeah, okay. Oh, did I not see this? Did I not see this before? Because the packetization shall be the entire package seated by boxes. It means that a progressive frame will have a single packetization unit, while interface will have two. The progressive case is illustrating figure 2. Yep. Okay. Very bit rate, or this can involve rate allocation, but okay. Dealt with that, and then the header. Okay. Yep. So really, what we're going to want here is a packetization unit or something like that. I mean, that's. I think this is a really bad name, but anyway. And this is going to have the header, and then we're going to have. Yeah, it's pretty much, yeah, made of an ADU. Yeah, really, this is almost like the, okay, I'm just going to write it like this, just for now. So we're going to have this, and then this is going to have, corresponds to a single, so this is just a frame. There we go. Okay, the frame, and then this, right? This is going to have the, and look, and we're going to have this sort of shit. Yeah, okay. I'm starting to see a little bit how this could work. Okay, so a frame then is going to have a bunch of, you know, PU is a slice of PU, right? And then, yeah, and then that's, That's probably it. Except the header is going to be... No, but the header... No, the header is going to be different for each of these, so we can't have that. So it's going to be type... Single frame. No, that's not right either. It's going to be the type is the packet. I'm just trying to work out whether this header is the RTP header or the JPEG XS header. To me, it's not clear. So this is going to be the, where's the coaching? The format of RTP header, yeah, sure, okay, RTP header, we've done that, that's fine. Payload header. This is payload header, yeah. Yeah, each of these is going to be P. Tricky. Oh, sorry, missed lots of. You see what I'm working? No pressure if not. Wait, shaded to. I'm working no pressure or not. I think it makes you pick no advances. Comic mono. Yeah, that's that comic mono one is crazy. There's no pad for I love it. Is that though? Oh yeah, it's all good, right? It's all good. You have to cut an MS Word. Yeah, that's it. Yeah. I actually think writing in Microsoft Word would be good because, you know, then you can print out the code and you can be like, have I written too much code? And you can see instantly how many pages there are. So you can just like measure like whether you're writing like too much or if your implementation's too complicated just by the number of lines of, you know. Elon Musk was, oh. Yeah. No worries. Thanks for popping by. Yeah, do you have a link? Oh, I don't know if you're gone already, Urban Dre, but yeah, if you have a link to it, then yeah. And Catherine asked any of what I asked earlier. Oh yeah. Do you have a link to the source code also? No worries. I'm interested in seeing the shader toy. I don't know what shader. What is shader toy? No, I can't because my computer, like my main computer, is too slow to run that kind of thing. So, yeah, just yeah, that's pretty much it, right? Like it just kills the battery, and yeah. It's a website where you can code shaders that render directly in your browser. Okay. I'm not 100% sure what a shader actually is. So a frame consists of multiple packetization units. And each of those PUs is going to have oh yeah, cool. Oops. Oh yeah. Okay. Hold up. Let me keep going with this stream because it's being recorded on YouTube too. So yeah, just want to make sure that I got to stick a little bit on topic just because yeah. No, but I'll save this. And then yeah, that's good. And then I've got that. So definitely this. That's for sure that. The first 4 bytes of the payload of an RTP packet. Aha, okay. So in this case, you have the header, and then you'd have maybe from here would be that packets are sent. Thus, each video shall define the same subboxes. The effective values in the boxes. Okay, each frame in one of my packetization unit is explained in section 4.1. Okay, let's go back up here. Yeah, so in this case, this is the actual. This header is this header. And a packetization unit can span across multiple packets. But each of them has to have the header. So really, it's going to be like, you know, it's going to have the shall conserve under the packet shall be the first. The first byte of packetization shall be the first byte of the payload, excluding its header. Yeah, okay. Each packet shall contain one and only one packetization unit. Yeah, okay. So what this is saying is that, yeah, you can't have overlapping. So you can't have 1 and 2 in a single RTP packet. So how can I represent this? Let's say... It's going to have to be like this, isn't it? It's going to have the packetization unit. Packetization unit is a, you know, this. Just something, I'm not doing this properly yet. And then boundaries of the payload of a packet, excluding the, yeah. So really it's that. And then this is going to have a whole bunch of other shit in it. Like that. Now, whether or not that gets split up across multiple RTP packets is, you know, whatever. But that'll be something like, yeah, that can be handled by the library. So these video box and the color boxes, they come from the actual JPEG XS spec. Synchronization source. Okay, this is divided into application data units. Each ADU corresponding to a single JPEG XS frame. I don't quite understand the point of that, because like each ADU corresponding to a single JPEG XS frame. Really, it's going to be like this. So a frame is actually almost like that. Yeah, like that. That's what it looks like. But we don't need that as a separate type. So what we could do is actually just work on maybe encoding this. Yeah, so like all right, so let's so we know that it's going to be 4 bytes, so we can use an array here, as that's useful. Payload header. All right. Okay, so here we go. If AO 1, 2, 3, 1, 2, 3, 4. Let's do this. So the transmission, okay, so we're checking if this bit is set. Right, there we go. And then let's go. The packet mode is one, 2, 3, 4. I mean, we could really do one shifted, so like on no, that's all right. Okay, let's do that. 0, 1, and then 1, 2, 3, 4, 5, 6, 7, 8. Another, okay, last. Okay, here we go. So the interlaced information, that is our interlaced info. Two-bit field, yeah. So we've actually stored this, like, sorry, we represent this as an actual bit field. So, sorry, not there. Where's our scan mode? Oh, sorry, yeah, it is here. Yeah. So 1, 2, 3, yeah. So what we can do is we can just store it in one go. So interlaced info. And then we just do the bit mask. So we want to skip those 3 bits. We want those ones, and we want to ignore the rest. So that's 1, 2, 3, 4, 5, 6, 7, 8. Like that. But that's scan mode. So just do a type conversion there. So we're just reading those 2 bits out of that byte and storing it in there. Okay. 5 bits. 1, 2, 3, 4, 5. Oh my God. Okay, we need a little diagram. Our favorite bit field diagrams. Okay, so this is AO. I'll put this in monospace to get a nice diagram. So we've dealt with 1, 2, 3, 4, 5. And then we want 5 bits. So that means we've done 5. So we've got 3 left. 1, 2, 3. Now let's go A1. So let's actually call this the F counter. So let's just call this F. F, and let's just do this as 0 just to say we're done with it. Okay. And then that's 3 bits, so we want the next 2 bits, 1, 2, and then we could actually do this as maybe, let's call this S. So we got the next 11 bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ugh, okay. And the next is P. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Nice. All right. And then there's our 4 bytes done. So we've got to get this stuff now. So this is a this is the frame count. Is a uint 6. Oh, it's 5 bits. Okay, so we're storing this in a uint 8. So that means that we're going to grab those. Oh, this is big endian. So, oh no, wait, it doesn't matter. We're in 1 byte. So it's going to be those bits. So that's A0. That value and these 2, but shifted a bit. So let's actually just do this and split it out. So we get that, and then age to frame count. Those 2 bits. So that's that'll be 1, 2, 3, 4, 5, 6. But it's not that value, right? Because we actually want to put them somewhere else. No. These ones, oh, fucking hell. I hate this stuff. Is what we really want is these 3, 1, 2, 3, or rather in our representation, we want 1, 2, 3. And then this one, so 1, 2, 3, from those 3 go there. And then the other 3, so let's do the other 2, sorry, and 1, 2. Or is it the other way around? Is it going to be like that? Or like this? If it's in network order, it's going to be like that, I think. No, wait. It's going to be... No. Hold up. Every time I do this, I always get a bit confused. So I've got a 5-bit integer and I always forget this. Always. What I don't know if I need to shift the bits. God, I was doing this before. I just can't remember now. If I move... Yeah, I'm pretty sure it's like that. Yeah. So we've got to shift these along too. So we're going to shift this along like that. So we make room for these two. But then these need to be shifted all the way along 6 positions. So we're going to mask off, yeah, because we only want these 2 bits, but we want those 2 bits to be, let me get rid of that. We want these 2 bits to be up here, right? So to get them there, we're going to first get the value, and then we're going to, we've masked it, and then we're going to shift it to the right 6, something like that. Yeah. I think that's it. Yeah, because then we've got, so then our value, yeah, we've got 3 bits shifted to, this is 1, 2, yep, so those are all there. Those are just 0 because we don't care about them, and then these are the 2 from the next byte, and we've pushed them into here. I think that's it. So that should be right. I just don't want to, I don't like this order thing. Like I don't like having the, yeah, like that needs to be, yeah, because then we've got our byte and then we shift it along 6, but then we need to assign, yeah, we need to put it into there like that. Yeah, so I think that's it. Okay. What do we got next? Uint 16. Okay, 11 bits. All right. So let's, so in this case now it's going to look a little bit different. So we've got an big endian uint 16 in here. So that's going to be, but sorry, it's not a uint 16, it's a 11 bit. So let's count that out. 1, 2, 3, 4, 5. We've got 1, 2, 3. Okay, that's 1 bit, 1 byte, sorry. And then we've read 3, so those 3, and then we're going to have 1, 2, 3, and then we're going to read the rest of them. So 1, 2, 3, 4, 5. So let's count if that's okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. Okay. So that's our, yeah. So a little s for coming from this byte, and then big S for those ones. So let's try and get that in. Ugh. Okay. 1, 2, 3, 4, 5, 6. Right, so the first byte, yeah, okay, so let's try that. So header dot, this sep counter equals, okay, we're gonna read the big end in uint 16 out of, let's do this. Step C. 6. Oh, sorry, no, A1. Yeah. And then those 5 are coming from A2. Okay, so this is everything but the last 3. So 1, 2, 3, 4, 5, 1, 2, 3. So now what we're going to do is we're going to shift 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, okay. Why doesn't this feel, doesn't feel right to me now? No, but that's, yeah, no, that's right, yeah. So that's going to be, yeah, I think we want it like that. Okay, so, ugh. So we're going to grab the 3, we've got 3 bits, or we want those 3 bits, so let's get them out. So that's 0, 0, we're going to have 1, 2, 3, and then 5, 1, 2, 3, but we're going to shift them 3 positions. And then the second one is going to be, so really we can actually just do it like this. Oh, no. Okay, and then we need to get those 3 bytes, those 3 bits, and then those 5 bits and pack them in. Yeah, okay, so let's go A2, it'll be 1, 2, 3, 1, 2, 3. This is shifted to the left 5. And then we need to do another one where now we get, this is A1, sorry. Now we get A2 here. So let's get that. But those need to be shifted to the left 3. I think that's our Now then, to store all of that in a we got that in 16. Like that. So I think that's it. I'll need to check that. Yeah, let's keep going after that. So I'll come back because I'll need to like add some comments here because this is just like, what the fuck is this, right? This needs a little bit of explaining. So I'll probably even just start off with this. You know, so we'll do step C1 equals that, and then like that. Yep, that looks better. And then we need to, this is going to be a little bit easier now. Actually, a lot easier. A lot easier. Yeah, okay. So now our packet counter. So packet count. I want to call it packet count, not packet counter. Yeah, that's better. Yeah, actually this is super easy. So now all we need to do is we actually just give it just straight up, I think, A3, and then done. Yeah, because we've got the, oh, sorry, we need to mask the, so 1, 2, 3, 4, 5, 1, 2, 3, and then that. So, because, yeah, all we're saying is, hey, read the integer out of this, and because these are already aligned, like they're already to the right or whatever, so yeah, I think that should be it. Okay, and then, and there's a little error we can check, which I will, yeah, we'll do that in a sec, but let's just grab that. Missing in the composite literal, okay. All right. There, it's pretty, yeah. From that into the, just do error. Okay, all right, cool. Andrew, never gonna hear, can you suggest what approach should I, and to get as good as you love what you do, man, I feel inspired watching. Oh, awesome, hey, listen, that's awesome, thanks for saying that. Well, I would, I think a good place to come from is something that you maybe have done before, and it can be anything, right? And try and find a thing that wasn't quite quite how you felt. Maybe you didn't feel it was good enough, or you personally would like it in a certain way. And yeah, I guess just try to do it like that. Was there anything like, is there any particular domain or like kind of industry that you're interested in? Like, are you interested in like graphics or biology or I don't know, really anything like that? Okay. Okay, cool. Okay. All right. So, yeah, awesome. Okay, well then, I guess from there, maybe you could, come up with different ways to use the WebSocket or, your WebSocket thing. So, for example, if you're interested in that kind of stuff, one of the fun things to do is like maybe use it to like proxy from one type of transport protocol to another one. So for example, like, can you write a little program that takes in like datagrams over the network, sends it through your WebSocket thing, and then can receive at the other end, and is the message okay? Yeah. Yeah. Because, yeah. No worries. Yeah, something like that. Yeah. Because then you can kind of hook it up to like real world things, for example. Just like, and I mean real world, like, I mean, I don't know, like, can you send like DNS messages through your WebSocket thing? Why not? I don't know. See what happens. The trick is that it's not necessarily about getting a useful application per se, but it's about like learning about that kind of thing. I mentioned datagrams specifically because, yeah, like TCP does a lot. And so if you, when you don't have it, you run into things that can be confusing. Or you kind of learn actually, oh wow, like I understand now what it was doing all along. Yeah, but I'm no expert or very good, right? Like I'm learning, so and the learning never stops, right? So I don't think there's any destination or anything. I think if you just enjoy doing that kind of thing and like still learning, then I think that's really cool. The one thing I would say for me personally, I think something that is sometimes, yeah, I don't know. Yeah, I think, yeah, also, yeah, focus on debugging and stuff like that, like trying to make things, sure, like, of course, you want to be really fast and you want to like know lots of different languages and different like frameworks and all this sort of thing. Yeah, sure. But there's these constant things throughout the way that I think are, important, like debugging, problem solving, testing, documentation. Yeah. So, and I think that makes the job easier because, for example, like if I'm better at documentation, then I can read this sort of thing and say, oh yeah, okay, I kind of get that now because, you know, I can see why they split up the documentation in this certain way. And if I've read lots and lots and lots of different specifications, and if I've tried to write one myself, then when I come to reading the, you know, RFC 9134, the RTP payload format for JPEG XS, then I go, oh yeah, okay, I can kind of read it a bit more easily. So then the code is better because I've understood the spec better. And so there's, for example, there's not as much unnecessary stuff in the code, for example. I just made that up, but I guess, yeah. So sometimes any project is okay because there's all these constant sort of skills and stuff that you always end up having to use. Yeah, but it's interesting. Thanks for the question. It got me thinking too, yeah. So yeah, I think let me I'm gonna go for a quick tea break and or maybe a lunch break depending on the time. Yeah, I might just let me just grab my 2 seconds. Like says that happened to me the aha moment today. Yeah. It's good, hey? It's a good feeling. Okay, give me a sec. I'm gonna where's my oh yeah. Okay, let me grab my little gophers. Hold on. Don't know if that's going to stay there, but let's try it anyway. Is that there? Is that okay? Yeah, it looks good. Cool. All right. Okay, see you in a few minutes, I think. What's the time? Yeah, just a few minutes. 5 minutes, that's all. Thanks, guys. Thanks, everybody. Actually, my eyes are gonna. Oh, I need that sun though. Look at my sunglasses. Hold on. Okay. Hi. Just rearrange some stuff. All right. Hello, world. Shit. Sorry. All right. There we go. Where are the... Alrighty, so thank you. Okay, now what's next? What's next is the question. Let me, now that I'm back and I've got a tea here. Let's see if I'm right in thinking about this stuff. So yeah. So I'm just checking that this stuff is, well, both, yeah. Suka copy. All right. Thinking how to get is this the same in Malay? Suka copy? I think in Indonesian is yeah. 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 I don't understand. Yeah, I don't. Yeah, in Singapore, but it's they speak Malay in Singapore too, right? I mean, I know English. I know, yeah, but like, okay. Yep. No, as an I. Yeah. Okay. Yeah. Interesting. Yeah. Now let me study this again. So. Why? So when we get we want the 5-bit integer, right? So we're going to have why are there the zeros? Those are our, yep, okay. 5 bits. So we get the frame count is 5 bits. Yeah, so we go 3. And then those bits from there and then shift it to the right 2. Yeah, okay. Yep. So same principle applies for this for these, where you've got the S for the sep count bits. Got here the first do I need to pack it like that though? Can I not just I think I got this wrong. I think I want to go like maybe I want to do it like maybe it's been too long since I've done this, because if I've got 15, what is this, an 11 bit, right? So then maybe what I really want to do is 1, 2, wait, how many is that? That's 1, 2, 3, 4, 5, 6. Maybe it's 1, 2, 3, 4, 5, 6. 1, 2. Three, 4, 5. Maybe it's this, and then the rest is just whatever. So if that's the big endian, let me have a look at my other weird bit integers. So in the mpeg transport stream, there's a bunch of stuff like that. Here, you've got these timestamps that are like, 33 bits. I've got a little diagram for it. Here we go. This is it. Okay, so in a mpeg transport stream, you've got this stuff. So when I'm reading a timestamp, it's packed like this. You've got 3 bits in that, like in that position in this byte here. So how would I read that in? The 2 leading zeros are padding bits. Yep. P and D hold the values PTS and DTS in the timestamp. Yep. The ones are check bits, which must be toggled. That's ones. T's are the 33-bit big endian encoded integer. Yeah, okay. Thank God I wrote this documentation. So that means I'm expecting to see on A0 in this array, I would want to be what are these bit masks? It's the thing that I'm confused by. Oh, yeah. Okay, I got it. Yeah. Okay, so when we read one bit and put that into, yeah, so it is like this. So it's the same here. So what we do is we grab 3 bits. Yeah, that's it. Okay, cool. And then, yeah, all right. So what we do, let's just confirm, okay? So that's our layout. This is our layout that we need to, yeah, that's the layout that we kind of want. And then 3 bits here. So we need 3 bits. So we get that and then we shift it 1, 2, 3 to get it to there in that position, and then we're good. Then we have 3 bits left. Like we have 3 bits remaining that we want to get. So we get them and then we put them in the position that we want, which is there. And then we read, and then we just read the rest of it. So that'll be those 5 bits, but then shifted into the position that we want, which is here. Yeah, okay, great. That's right. We got it. Yeah, documentation. Yeah, helps. Okay. So yeah, that's it. Okay, we could try a Marshall header now as well. So what this is going to look like is we're going to have a header, and we want to return an array of 4 bytes. We're going to go back the other way. Okay, so header.sequential. Then we toggle, yeah, we're going to toggle that bit. So that's the first bit there. Like it's clearer doing the. Okay, now the interlaced info. We can just pack it straight into the byte that we've got because we've stored it, in the position that we're sort of storing it in the wire format. Let's put it that way. So we're storing it like as the bit field rather than as like an integer value or something. So let's do that. So we're going to go the header dot scan interlaced info. Okay, frame count. So again, we're back to here again. So we're going to do the reverse of what we just did pretty much. So we've packed all of those bits in like that. So now we need to get 3 bits. Three bits out of frame count and pack them into that byte there. So that's going to look like, and we're going to look at this thing here. So we care about this one. So that's how it's laid out in memory now. 1, 2, 3, 6, 7, 8. Yep. Okay. So A0. Okay, so we want those 3 bits. So maybe 1, 2, 3, 1, 2, 3, 1, 2. But we need to pack them into this. So we need to shift it because we need to shift it along 3. So we need to get our 3 bits and go 1, 2, 3 and put them in the position we want is at the end there. So it's 1, 3 like that. One, 2, 3, 4, 5, 6. Oh, I might have fucked something up here. 1, 2, 3, 4, 5, 6, 7, 8. Oh, sorry, no, 2 positions, yeah. Sorry, yep. Because we want to put them at the end. So, well, rather we need to put them at this direction. Okay, and then we do the same, but we'll do some similar sort of thing. So we want the rightmost 2 bits out of the frame count. 1, 2, 3, 4, 5, 6, 7, 8. Well, we want those 2 bits all the way over here. So it's actually going to be shifted 6, like that. Okay, done. I'll just say in our scenario here, we've got 3 bits, so 3 bits remaining in AO. Yeah. And then we run into that, and then pack, and then this one is now we're pack remaining 2 bits from into leftmost 2 bits, leftmost bits of A1 there. That's what's actually happening there. So that's good. Okay, we've done the frame count. Now we need to do our sep count, which is 11 bits. Pain. So how are our 11 bits stored in memory? 1, 2, 3, 8. So that's how we've got it in memory right now. So we'll need to get those. Yeah, we have to do this thing backwards. So we want that. So we've got 6 bits in there that we can. So let's grab six bits out of. Sorry, let's grab 3 bits. What have we got here? Sep count? Yeah, okay, so we got. Four, 5, 1, 2, 3. So this is our layout that we've got. Wait, is that how it's? No, that isn't. Hold on. I mean, because we're stored in little endian. So do I need to do? I mean, at least on this architecture. So I want to actually. I think I need to. Yep. All right, what I'm going to do is I'm going to. Let's test this. Okay. Let's get some bytes. So let's say. One, 2, 3, 4, 5. Let's go like, 1, 0, 1. And then that one is 1, 1, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, like that. So. Okay, so that's our I in whatever endianness our architecture is. So now let's go and yeah, okay, I got it. What's in the binary package beginning to put uint16, I think. Like that, oops. Yeah. Hold on. Coding binary. Put. Yeah, that's it. Okay, so I'll just make a little. Okay, we're going to put our sep count into that. So now we can do some binary operations on it safely. And this does the whole, like it manages the endiness for us. So that's portable. Okay. So we're going to start. Okay. So again, yeah. So now we've definitely got this representation. Okay. So let's get the 3 bits out, which we've got. And then we need to put that into those 6 bits. It's not that, sorry, that's this. So this is B O. Oh, hold on, next 3 bits. Ah, no, that's here, so B1. 1, but we only want the 3 bits, so 3, and then 1, 2, 3, 4, 5. So we want to take those 3 bits and put them here. So that means we got to shift along 5. Whew. Okay. Now we get the remaining bits of, so we get these ones, and we're going to get that into A2. Okay, but then we need to shift it, I think 3, yeah. Okay, that's B done. Now, we're going to do the same again, but for the packet count. Let's do that. So make, I mean, no, we're going to do a new, so okay. So we've got packet count in the bits that we want, and our packet count looks actually identical to, let's get rid of that because that's wrong. So our packet count looks exactly the same as this, I think. Yeah, because it's an 11-bit integer. So we're going to do the same logic, I think. Yeah. I mean, if I wanted to really save some memory, which actually maybe we might want to be for quickness, this is actually, how do we zero the, how do you zero the bits? That one. Can I do that? Is that gonna? This is actually, this is like code golf or something. What's going on here? This. Yeah, okay. Oh, I'm not allowed to do that. And then where are we going from there? So then we've got the same thing. So A, so we've got those 3 bits. Oh, we can just directly, right? Because we just want the 3 bits there. So that's easy. So this is actually just that 1, 2, 3, 4, 5, 1, 2, 3. And then A3 just equals B1. And then that's it. We return A. Okay, that's our JPEG XS header packed. So that's all right. It is. It's back. Back and badder than ever. Yeah, so I think that's all right. I mean, yeah. No. Nah. No excess. I don't get how you do it. My brain is fried after a few hours. Yeah, well, I've been going for 3 hours, so it's, yeah. I think after 2 more hours, I'll be starting to really feel it, but I feel okay right now. Yeah, okay, so that can, actually, no, that can stay. That's whatever. Okay. Yeah. One, 0, 0, 0, 1, 1. Yeah, yep, okay. Yeah. Okay, now. Okay, so we've done that. It's not really doing anything. That can go. We're not doing a transport stream. I guess there's a few constants that we could save in here, or at least color related.
required to really search as color primary shadow characteristics, blah, blah, blah. A marker that consists of 2 bytes OXFF11 indicating the end of a JPEG XS code stream. This image format. So maybe now we could look at we could probably try to fill this out more, okay? So right now, let's ignore that. Let's just look at this. Okay? So this is like what a JPEG XS payload looks like. So this is gonna be, this is one packet. So if we had our, so in sort of code form, it would kind of look like this. If we had a RTP packet, that's going to have out its own header, and then the payload as a byte slice. But what we're doing is that we're saying no, like our payload now can be a jxs.payload. So what we'll be able to do is read we've got RTP packet. We'll be able to take that byte slice and decode it, some of it. Right now we can get the, so if we've got a JXS payload, so that's what our JXS payload looks like this. It's got its own header, and then it's going to have this thing like a packetization unit or a PU. And that thing has, you know, some of these boxes and blah, blah, blah. Like that. We've done the header. We could try, yeah, I don't know. But I don't know. It feels like I'd really need to go digging into the spec. And let's say I do not want to pay like $500 for the specification. I have been provided with the specification. But I don't really want to like open it on the stream, and you know, I don't know. It's like, yeah, I'm wondering how to do this. Okay, so we have some code. Let me show you. We've got very, very tiny little bit of stuff to be able to try to decode. Here we go. So there's our code stream. So in our packetization unit, we have, you know, it'll actually look like a, I mean, the packetization unit could also almost just be a, you know, we got the marker and length, so then it has all its own stuff. So this could almost be, the packetization unit really maybe should be like a, yeah, I can't remember how it's laid out, but you can sort of see how it all fit together. Surely come knock at your door. Yeah, well, it's just, I don't know. No, it's just, I don't know. It's just weird. Like, I also, it's so big.
like it's hundreds and hundreds of pages. So it's not so much that, it's just like, I don't know whether it would be so boring because I would just be like banging my head against this fucking huge spec and at the end of it not necessarily have too much to show for it. Of course, it would be like the world's first open source thing, which would be cool, but I don't know, like I don't have a, I don't know, do you know what I mean? Like I kind of, I didn't even know any equipment that can produce JPEG XS. I know it exists like in big sort of expensive hardware, but I don't know. It's yeah. Any thoughts? I might just comment that. What would the code look like? Like say we had this, right? We've got this code here. Let's have just a function. Okay, import RTP and import JXS. Yeah. So let's define a So we need a way to read in a JPEG XS code stream. So let's say that we had a way to do that. Like let's call it like, frame is, JXS.decode. Let's send it in. This is kind of how I imagine it would look like. And actually, what it would look like is an image, yeah. Oh, we can do frame. And then we would have our image.
would give you all of that stuff. Maybe this would just be like that. And then a frame would have all of this shit in it. And then we need a way to split that up into these PUs. Right, so the payload I would say like, yeah, let's do jxs.payload. Now we'd start filling it out. So sequential, let's say yes. Packet mode. Whether the packet is a last packet, no. Okay, interlaced info would be dot progressive. That's what we're doing. Oh, just 0. Okay, so we don't need to set it. Frame count to which the packet belongs. This would just be 0. And we put that there as explicitly. Okay. We'd even have a loop, right? So for whenever packet counter overruns. Okay. I'll leave that as 0 for now, and then packet counter is an 11-bit integer identifying the packet number within the current packetization unit. Identifying. Yeah, okay, so that's if the identifying the packet number within the current packetization unit. No, I haven't quite got that. Okay, I'll get that in a bit. Let's leave that as 0. Maybe to packet count is to 8 of that. So then I'd try and get it all in here now. So I'm assuming that we've got these boxes in every frame. So that means it would be like frame dot, because we've got a frame dot video box, frame dot color box. I'm doing American spelling. And then some other stuff. So then our packet, let's say our payload would be that, and then we'd say like, we'd have a marshal, right? We'd turn that into bytes somehow. Something, I don't know. We go into our packet. The header is okay, whatever, we don't know yet, and then the payload would just be B. And then we'd send it off. So we'd, whatever, like we'd have a session. Let's say we send it to, just here, 5004. Okay, there. So that's like some draft code that sort of, really that's kind of the code that we would eventually want to work, where we somehow read in a frame, put it into a RTP payload, put it into bytes, of course, and then put it into an RTP packet, and then transmit the packet. So we have all this stuff. We've got the transmit. We have the session. We have a tiny bit of marshal payload because we know how to do the header. But yeah, that's it. So yeah, that's a good little note to have, I guess. So this, for example, could be used to, like, I don't know, let's say you're reading some JPEG XS files from somewhere, I don't know where. Yeah, there you go, you'd send it off. Now, a similar thing actually exists, but not with JPEG XS, but with motion JPEG, which is just standard old JPEG. So with the, literally with the, JPEG image. So rather than JPEG XS. So yeah, that could be, yeah, I think, yeah. Maybe we'll just save. I think that'll pretty much be it. It's just that I don't know how many of these we'd get out. So how it is that for a given frame, you may have multiple payloads. So really, this would be, you'd have a function, let's call it packetize, and then then you'd have your PU, or your PUs is jxs.packetize, and then you'd pass in the frame. Okay, whatever. And then you'd go and you'd make up, so then you'd go for underscore PU range. Yeah. I think that's it. Yeah. Then yeah, that's it. That's it. Here we go. This is it. Right? No, for J. Okay. Payload, bang, 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 bang. Yeah, yeah. The packet count in this case would actually be whenever packet count overruns. No. I think this would be packet count. Within the current packetization unit. I need to look at that again. Nine one three four. Oh, whoops. Let's read this. Then you'd have to work out, like, Who would work out how to split this up? Because you're gonna do it frame by frame, right? You're gonna get a frame, and then you'll decode a frame, and then you'll pack it up into you decode a frame. You're going to get these sort of packet units out of it. And then you need to work out whether how many. Yeah. So you may or may not get that many. Yeah, we're sort of specifying a payload, but it's not. We're going to get. Oh no, it's going to be here. It's like that. There. So that is like that, and then the header, yeah. Yep, there we go, that's better. But that, how is that going to be fragmented? Who will do that? It's almost like you need to take a payload and then return a bunch of RTP packets. There may be one, there might not be, but yeah. So it's going to be, you're going to get a frame, you're going to have a bunch of packetization units, and then you're going to, loop through, set the header, and then the whole packetization unit is going to be there. So that's okay, because you don't care about the parts yet. It doesn't know or care. So that's our payload, and then we're going to go like packets is like a from the payload, like that, so you'd have like, let's put a pointer there, turn it into packets. And that would actually give you an RTP packet, perhaps. and there'd be errors there. And then, okay, so if equal nil, then you just, I don't know, and continue onto the next packet unit. And then that, maybe you'd get, yeah, that. Okay, so for underscore p range packets, and then go again, do another loop. I mean, normally you'd okay, so in Go you'd have the concurrency going on here, right? Because yeah, like, you know, you'd have one thing like decoding, and, you know, decoding the frames and putting it into payloads, and then you have another Go routine that's like consuming them and sending them off. But for now, let's just do it like this, nested for loops and stuff. Right onto the next one. Yeah, okay, there we go. I think now that's what I think it would look like. It's kind of gross, but yeah, like we definitely tidy that up with, you know, we'd use concurrency to try and like make it clearer what's going on, because one side isn't really dependent. Oh, one side is only, yeah, like, yeah. We'd split the program up like that. Yeah, I could even just do it here. So like a transmit function. Something like, oh, and then packets would be a receives of chan. Oh no, I don't know, just point a packet, and then yeah, just like that. Okay, and then we just go for, whoop. Let that do its thing. So we do here, ch is a make. Oh, and then we would go packets. And then what would we do? We would send it through. Right? Well, man, it's still the same, isn't it? He starts to serialize. Why? How could we could probably make it clearer, but yeah. Probably, yeah, damn, sucks that we have errors there. Like, I wonder whether we could, no, we're going to have errors because we're going to be marshalling stuff into bytes and all that, so anyway, whatever. Yep, I mean, whatever, yeah, maybe. Okay, there. And then we'll probably split that up a bit more. somehow. Pretty sure that's J. So there's some pseudocode. We could change this to the payload. So we could have a thing that reduces, yeah, so we'll probably do that actually. Let's say jxs.payload, rtp.session. That actually is good, yeah. Range payloads. Or we'll just do packetization. What is this? Yeah. No, yeah, whatever. Okay, and then the payload, yeah, would be the payload chan of jxs.payload. And then this would be packets, yep, okay. So we've got one. So we've got the main routine going through and getting the, yeah, decoding frames and turning it into RTP, oh, like a JXS pack, you know, one of these several, what do you call this? Payload, yeah, into, yeah, turning it into JXS payloads, sort of, yeah, something like that. And then the other one is reading in the payloads, packetizing it, transmitting it over RTP to whatever the other, you know, whatever the receiver is. Now, to me, that's what it should look like. So if we had a file on disk that was, a very large JPEG XS, a very large file concatenated JPEG XS images, then this code would send it over RTP to a receiver and they could watch it. No sound though, because you need 2 RTP streams for that. One for video and one for audio. Now, yeah, well, that's, yeah, that now this code doesn't exist. So we've got the header, yeah, we're handling that. What else have we got? We've got, this doesn't exist. This would probably have to take a, yeah, we'd have to give a size here. So this would tell this function, hey, like split it up over, given a packet size of this, which would probably be, 1492. So typical network MTU. Something like that. Or we could just do this MTU. Easier, because we're looking a bit, it's a bit of a deep thing there. Yeah. MTU. So that's an interesting design work. So what we could probably do from here is like maybe almost try and write some of that code. Like we can't because we've got no idea what the actual we don't know how to make payload unit, packetize the PU. We don't know how to make that. So we can't, and we certainly don't know how to decode it. So now that said though, might be able to like almost like fudge it or something and just, I don't know. Yeah, we'd have to work out how to split the, yeah, I don't know. So we'd have a packetize function. Okay. And take another quick tea break now that we've sort of done a good bit of design. We're done with that. That. That's done as well. Let's save this.
Okay. Oh, yeah, the sun's just gone down over the thing. Nice. Oh, still a little bit. Okay, I'm going to go for another tea break because it's nice. Oh, sorry, Bobbies. What is the editor window manager I'm looking at here? This is the Acme editor, originally from Plan 9, if you've heard of that research operating system. I have a link. Another one. Yep. Not sure if you're still here, but yeah, that's a fun video from, just covers how Acme works. Yeah, okay, cool. Yeah. So that kind of walks through the editor, like how it works, what the kind of model of editing is, and its idea of how text works and stuff like that. I haven't watched that video in a long time, actually, but yeah. And yeah. No, it's good. It's good. It's good fun. Interesting way of thinking about text interfaces, I guess. Yeah. Yeah. Anyway, I'm gonna go grab some tea. Also, gotta go to the loo, so I'll do that, and then I'll just go. Oops. I'll do this. Oh, the thing fell out. Okay, good times. All right. See you in a sec, 5 minutes or so. Okay. Hey, what I'm actually going to do is actually grab some late lunch. So what I'm going to do is change that sign. It's going to be... Okay. Okay, there we go. All right. Okay. See you in a little bit. Oh, hey there. How you going? So I'm just about to get a very late lunch. Thank you. Thanks. Will do. All right.
Oh, 3 a.m. late. All right. To wrap this up, I mean, let's just. So we've got the RTP. Yeah, not sure how to design this thing, because I don't know whether this is like a JPEG XS. It's not the JPEG XS header. It's the like the you know, like the payload header or the something like that. Not sure how to work it, because I want like I don't know. Maybe what I'll do is let's put this into a JXS package at the root of the module. So we got this one here. Let's grab like, because we might be able to just get a tiny bit of it. What I mean is that like, if we get like maybe we only need to get like the header of the, like similar to what we do with MPEG transport stream. We don't try and like really understand what's in there too much. We just get enough that we can transport the contents around. So we could do the same here. Let's let's do this. Let's save it to JPEG XS, JXS, and let's call it like, you know, payload. So now, all right. Yeah, so I mean that's a little start. I think from there, like, might cut the stream on YouTube because it's probably reached the end of the sort of useful stuff that maybe could be watched later by somebody somewhere out there. So yeah, let me cut that. And let's go here. How do I do it here? Okay, so YouTube. Yeah, thanks for watching YouTube. See you next time. I'll try and think how to handle this thing next. It's tricky. It's a lot to bite off and it's a lot to chew, so we'll see. All right, thanks. See you next time. Ciao.